Carnegie Mellon University's Venkat Viswanathan discusses the challenges and opportunities of battery-powered flight in a perspective published in the journal Nature. Viswanathan, an associate professor of mechanical engineering, summarizes what that piece explored.
In this perspective article that we wrote, we tried to answer the following question, which is that what will it take to really make a dent in electrifying flight with battery power for small, medium, and larger aircraft. And I think the key message here is that the kind of batteries we have today are insufficient for many of the kinds of missions that we take routinely. So, there is a fundamental rethink of the battery chemistry that is needed in order to be able to electrify aviation. And we identify some of those battery chemistries. In fact, it actually is a journey back to what we had originally discarded. In the 1970s, there were a lot of such candidate chemistries that were being explored. And now it's time to revisit them 40 years later with three important differences. One is now we have better tools. We have the ability to characterize and watch what happens at unprecedented detail. The second is we have the ability to use robotics and robotic experimentation to vastly accelerate the searching over any given design space, which allows us to optimize materials at unprecedented rates. And finally, we have machine learning, which will allow us to parse through the data and then find patterns that allows us to identify the failure modes and find ways to overcome them. All of this paired together, gives great optimism that we can address the electric aviation needs by inventing the next super battery, one that will have, several times higher performance than today's batteries.